Hi guys, welcome to this lesson. So in this lesson, we want to look at trigonometric functions. So at the end of this lesson, you should be able to define some trigonometric functions based on circle. Okay, so you should be able to find the exact values of trigonometric functions for any angle. You should be able to use coterminal angles to find the exact value of a trigonometric function, and then you should be able to determine the sine or trigonometric function of an angle in a given quadrant using reference point. Okay, so what are these trigonometric functions? We have six trigonometric functions. Okay, in JS3, you remember in JS3 or in junior school, the trigonometric function that you were told about is just three, so which you use a SOHCAHTOA. Okay, SOHCAHTOA, right? So which implies that sine theta equals to opposite over adjacent, and cos theta equals to adjacent, opposite over hypotenuse there, sorry about that, opposite over hypotenuse. Okay, and this is adjacent over hypotenuse. And then you have tan theta, which is equals to opposite over adjacent. Okay, so this is what you have in junior school. So we are going to build on this four. Okay, we are going to build on this three and derive three more, making six. So in this lesson, we'll be looking at six trigonometric functions that we have in further math. So the names of the six trigonometric functions along with their abbreviation is given. So sine, the short form of sine is sine. So SIN, some people normally call it sin. Okay, so and we have cosine, which is cos, COS. Tangent, short form is tan. Then we have cosecant, which is cosec. Okay, you can also write it as cosec. Then we have secant, which is sec, and then we have cotangent, which is shortened into cot. Okay, so these are the six trigonometric functions that we'll be looking at in this lesson. So these functions normally find their definition from what is known as the unit circle. Okay, so do you know what unit circle represent? What does unit circle represent? So when we talked about degree and radian, you can see that those one derive their definition from circle. Okay, 1 degree equals to 1 over 360 revolution. That is when you make a 1 over 360 revolution, you have 1 degree. And when you will make 360 degree is equal to 1 revolution. So that means that one complete cycle is equal to 1 revolution. So we can use unit circle to define this value here. So if we draw a arm here and then we form a triangle with it, so this will form a right angle triangle. Okay, so if this is the radius and this is let's say this is y and this is x, so since this circle is unit, the radius is equal to 1. Okay, since the circle is unit, the radius is equal to 1. So radius of a unit circle equals to 1. Okay, and then if we use draw out this triangle and we use Pythagoras theorem, so using Pythagoras theorem, we know that the hypotenuse is 1. This is y and this is x. We have that x squared plus y squared will be equals to 1 squared. So that means that x squared plus y squared equals to 1. So that is what you have in a unit circle. The radius is normally 1. Okay, and then we can use this unit circle to define sine, cosine, and whatever. So if we label the opposite, if we put our angle here, let's say this angle here is theta. Okay, we can say this is opposite, this is adjacent, and that is the hypotenuse, right? So that sine theta will be equals to y over 1, which is equals to y. Cos theta equals to x over 1, which is equals to s, and tan theta will be equals to y all over x. Okay, so this is what we basically have for a unit circle, and these parameters derive their definition actually from a unit circle. So we can extend this to secant. So when we talk about secant, which is equals to sec, so sec theta is equals to 1 over cos theta. Okay, so that will be equals to 1 over x, and cosec theta, cosecant, which is equals to cosec. So cosec theta is always equals to 1 over sine theta, okay, which is 1 over y. And then we have cotangent, cotangent, so which is cot, and we have that cot theta is always equals to 1 over tan theta, okay, and you know tan theta is 1 over x, this will be x over y. So this is how these parameters derive their definition from a unit circle, and their standard, they can be used in any form of calculation. Okay, and these are the values we have. So this is how to define those parameters from a unit circle, and the definitions are also valid, mind you. Alright, so what we are saying in generally, what we just described is that if you have t, if t is t, let's say t equals to a tangent line, not the tangent, not the angle that we are describing. Okay, then we can talk about cos t, sine t. Okay, we can define the angle in terms of this tangent. So what we have is that this tangent that we have here, this tangent line t, is the same thing as theta. So all the parameters we've defined in the previous one, they can be defined. And the first one, remember when you rotate anti-clockwise, you have positive angles. Okay, positive angles. And when you rotate clockwise, rotating clockwise from 360 degree, we have negative angles. Okay, clockwise equals to negative angles. So we have negative angles, another subtopic, so we'll be seeing how to work with it from there. Okay, so definitions of trigonometric functions. So let t be a real number, and let x comma y be the point on the unit circle corresponding to t. Okay, remember here that t is equals to theta. Okay, so sine t equals to y, cos t equals to 1 over y. Okay, cos t equals to x, tan t equals to y over x, for x is not equal to 0, cosec t equals to 1 over y not equal to 0, sec t equals to 1 over x, okay, x not equal to 0, and cot t equals to x over y not equal to 0. So you can see the standard definition of these ratios as we have written. So that is how to use unit circle to derive the 6 trigonometric ratio. So we can derive this trigonometric ratio from circle, and then we can also derive them from right angle triangle. Okay, so remember, as we have said earlier, and from what you've learned in junior school, so if you have a right angle triangle, the side facing the angle is called the opposite. Okay, and the other side, the leg, is called the adjacent, and the longest side of the triangle facing the angle 90 degrees is called the hypotenuse. And from this ratio, we can define our parameters as well, the functions. So therefore sine theta equals to opposite over adjacent, cos theta, sine theta, always using adjacent, sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, tan theta equals to opposite over adjacent. Okay, and we can define the remaining one as well from these parameters. So sec theta equals to 1 over cos theta, okay, and that would be uh, hypotenuse over adjacent. So cosec theta equals to 1 over sine theta, and that would be hypotenuse over opposite, okay. And then we have cot theta now, which is equals to 1 over tan theta, and that would be what? Adjacent over opposite. So this is how to define the same ratio using um right angle triangle, okay. So they also derive their definition. So